All right, what is up? Today we're going to be talking about chatbots, but really we're going to be focusing on natural language processing, which is the discipline of building machines that can manipulate human language. That's from deeplearning.ai. That's a website with some pretty good information on there. So, a chatbot is a type of LLM, which is a type of natural language processor, which does natural language processing. Generally, they can be split up into two broad but overlapping categories called natural language understanding or natural language generation. Most natural language generators are obviously going to have to understand language to generate anything meaningful. So, natural language understanding. What we're really trying to do here is take input text and output some additional information about the input text. We maybe want to group the input text in a certain way. Maybe we want to classify the input text, maybe identify some words or phrases. So, sentiment analysis maybe is going to say if a piece of text is generally positive or a piece of text is generally negative. Spam detection is going to say the likelihood that a piece of text is spam, or maybe just say that this piece of text is spam or this piece of text is not spam. And information retrieval, perhaps you want to extract all of the dates out of a piece of text. You need something that understands language to some extent to be able to extract dates. Perhaps these dates are not all numerical and there's some word representations of the dates that you would like to be retrieved as well. Obviously, there's other pieces of information that you'd want to retrieve that's not necessarily dates. Perhaps you want to extract all the names out of a piece of text. You need to understand the language in some respect to be able to do that. Then we have natural language generation. This is taking input text and outputting new generated text. So, natural language understanding does have output of text, but natural language generation is focused on outputting generated text, text that didn't exist in the input or doesn't exist hard coded anywhere. We want to create a human like response to the input text. Generally, we want the output text to be such that it is as if a human generated the text themselves. Obviously, there's a lot of overlap. To be able to generate a human like response, you're going to need to have some understanding of language in general. And again, these are just broad categories. So we have translation, chatbots, and abstractive summarization. Extractive summarization is a form of summarization where we're not using any of the input text to summarize, or we're mainly using additional generated text to provide a new take on the piece of input information. There is also extractive summarization, which is slightly different, and what that does is extract pieces of text from the input text and recombine it to form a summarization based on the input text. And that is more closely in line with natural language understanding because no new text is generated. But again, there is overlap. So that's the main beginnings. All right, so we have discussed NLPs, which are natural language processors, or NLP meaning natural language processing. And now we come to the chatbot side of this, the large language models, or LLMs. Now, not all chatbots are LLMs, and not all LLMs are chatbots. A LLM is just a model with a lot of weights and biases. Now, a model is the architecture of a neural network, and a neural network is the network of neurons, and these neurons are obviously not actual neurons, and the network of neurons is really more of a representation of the flow of data that is being multiplied and added by values that are random initially and trained later on and passed through activation functions. So the neurons can be thought of as the point at which the multiplication, summation, and activation function are all computed to result in a new value that gets passed to the next neuron. So a model is the way that weights and biases are organized and calculated, how the inputs are handled, and how the outputs are calculated as well. So large language models such as GPT, BERT, and Llama are all based on the transformer architecture. architecture, which is generally the best way to handle language due to its ability to access the entire sequence without increased computation time. So when we're talking about artificial intelligence with respect to chatbots, we're really talking about type of model that handles weights and biases in a specific way. That is all it does. It is trained on a large amount of data, and it has learned, quote unquote, to compute weights, biases, and use activation functions to output a desirable output. So that brings us to the end of this first video, where I give a basic explanation of NLP and LLM, which are basically the foundation of chatbots. Chatbots are LLMs, which are NLPs, large language models, which are natural language processors. Large language models are models that compute a lot of weights and biases. And don't worry if you don't fully understand weights and biases. The next video, next time, we'll talk about just that. Models are specific neural network architectures. Neural network architectures are ways to take an input and return an output using a specific method of computation. Transformers are the most popular architectures to form chatbots. So a neural network architecture is just the way the data flows from the in to the out. And there's a lot of ways to do it, and there's a lot of different use cases for each way to do each flow. Image processing generally uses a convolutional or diffusion architecture. Natural language processors generally use a time series architecture, including RNN, LSTMs, which are gated RNNs, and transformers. You can use either one for either, but at the end of the day, it's just a method of performing calculations. And transformers currently happen to be the most popular way to form a chatbot, to compute inputs that are sequences and return outputs that are also sequences. The input sequence is not a fixed length, and the output sequence is not a fixed length. That is all. We're just computing numbers. With a whole lot of training data and a whole lot of power and electricity, we are able to simulate human-generated text with a machine that can only handle discrete binary values. Again, next video we'll be talking about weights and biases. Obviously, if you have any questions, put those in the comments. You know I'm gonna respond. I really appreciate it. I'm still looking into a bunch of other things, actually, and I might put out something really quick today as well. I really appreciate the suggestions. I'm learning a lot, and I hope you guys are too. Have a fantastic Saturday, and I'll see you next time. Peace.